Welcome to today's webinar, Set Up Preconfigured Protections on AWS WAF. Our presenter today is Nathan Dye and Heitor Vital with AWS and David Ferrante with eVitamins. Nathan, Heitor, and David, welcome. The floor is now yours.
Thanks, Ryan. In this session, I'll explain why you should use AWS WAF. Then Heitor will show how to configure AWS WAF to protect your websites and web APIs from common attacks. Finally, Dave will share his real-world experience using AWS WAF to protect the eVitamins website. AWS WAF provides you with the tools to detect, block, and monitor malicious web requests targeting your applications. Customers use AWS WAF to protect against three kinds of malicious requests. First, customers need tools to protect their websites and applications from attempts to exploit bugs that may exist within their service. The most common example here are SQL injection attempts, which are designed to extract data from backend databases through bugs in your website. AWS WAF includes built-in rules that can detect and block SQL injection and cross-site scripting injection attempts. Customers also need tools to guard against content abuse use cases. Some AWS WAF customers operate publicly accessible web services for use by consumers out on the internet, but they don't want that content to be bulk downloaded by scraper bots. As an example, classified ad, website, or job boards are often open for that kind of public use, but they don't want that content to be bulk downloaded and posted to some other website. AWS WAF provides the tools to detect and block bulk downloading bots. And finally, customers need tools to defend their websites and APIs against DDoS attacks designed to overwhelm their service. AWS WAF has the tools and the scale to defend against web layer DDoS attacks. AWS WAF comes with metrics that can be configured to alert you of malicious attacks, and AWS WAF provides you with details about the request blocked by your rules, including all of the header details, the source IP address, the source country of the attack. These request details are useful for understanding the nature of an attack. For example, it's easy to identify the part of your website or API that's under attack by looking at the URL details of a malicious request. Since launching WAF, customers have told us there are 4 key benefits they appreciate. First, AWS WAF provides pre-configured protections that make it easy to protect against common threats. Second, we designed AWS WAF for fast rule updates because we know that customers often use WAF to mitigate availability impacting events, and they use their WAF rules to block those bad requests and restore web service availability. That's why AWS WAF changes go into sync worldwide in around a minute, and in many edge locations much faster than that. Customers can use that capability to respond to shifting attack vectors. So if a bot attack is cycling quickly through a number of different source IP addresses, customers can use the WAF APIs to update their blocking rules and mitigate those shifting attacks. Third, customers have already used the scale of AWS WAF to mitigate large-scale web layer DDoS events. On more than one occasion, customers have mitigated DDoS events that were more than 10 times larger than their normal traffic volume. And finally, customers make use of the flexibility of WAF's APIs to build their own security automation systems. In fact, after speaking to many of our customers, we've seen a standard pattern emerge for that kind of security automation. And it looks like this. Customers are building systems that, in many cases, are collecting logs that come from their websites or their applications. And on top of that, they're building technologies to analyze the log data, looking for bad patterns. Once they've identified bad requesters, they can use and call into the AWS WAF APIs to update their blocking rules and filter the bad requests from occurring again. And using that exact same concept, we've packaged up this advanced capability and it made it easy to deploy this setup within your own environment as part of the pre-configured protection suite. Today's protection suite includes 6 protections against common attacks. 2 of these protections make use of that advanced security log analysis pattern that's used by many of our customers. HTTP flood protection and Scanner and Pro protection work by analyzing your web service access logs looking for bad patterns, and if bad requests exceed a configured threshold, the requester is automatically added to a blacklist in the AWS WAF. The third protection makes it easy to add IP-based reputation lists to AWS WAF. With it, you can configure, with this automation, WAF can be configured to use auto-updating IP reputation lists to identify known bad networks using the Spamhaus reputation list, or potentially bad IP addresses sourced from anonymizing proxies. As reputation lists are updated, Lambda scripts will automatically synchronize them with the AWS WAF. And finally, Preconfigured Protection will also configure AWS WAF rules to detect and filter SQL injection and cross-site scripting injection attacks, the 2 most common injection attacks. Together, Preconfigured Protections can guard your website and APIs against common attacks. The configuration is easy. You can enable or disable each of the 6 protections with a simple user interface. And Haider will show you how to use that interface to configure these protections, and will demonstrate the protections in action.
Thanks, Nate. Now I will demo how easy it is to deploy and use the protection that we just described. Suppose that I have a web application like this one, which uses CloudFront to deliver both static and dynamic content, and now we want to protect it, use some security rules. To simplify the process of provisioning all components necessary to run the solution, we've developed a CloudFormation template. CloudFormation uses this template for automatic provision all resources. So let's start our demo. The first step that we need to do is open CloudFormation console and create a new stack. Here you specify the location of the template. For that, let me open the AWS WAF page, go to Preconfigured Rules and Tutorials session, and open the documentation about the solution that we are creating now. Here you can find all the information about this solution, how each component works, and how to deploy it. What we are looking for now is just to copy where the template is located and paste this link here. Now you set the name of this stack. Let me use demo WAF for that. And here in protection list section, you can select yes or no for the protection you want in your infrastructure. So for this demo, let's keep all the protection activated. Some protection use the information available inside CloudFront access log to decide which IP should be blocked, and here is where you specify the name of the access log bucket. I can use demo WAF C001. If this bucket doesn't exist, the solution will create and configure one for you. For the rest of the parameters, let's assume the suggested default values. In this case, just keep clicking next until we reach the last page, accept the configuration that we have here, and create a new stack. This process usually takes about 15 minutes to complete. I've created a stack in another region, so we don't need to wait for this time. We can see here all the components that were created for us. There are some important information here in the output section, output tab, where you can find info like which bucket we are using in this case. And the main building block that we have here is the AWS WAF itself. So if I open the AWS WAF console, we're gonna see that there is a webACL created for us, and this webACL contains a set of roles. Okay, now we have our protection layer provisioned. What we need to get everything working is associate this protection layer with our CloudFront distribution. For that, we can go to the CloudFront console page, select the distribution that we want to use, and click Edit it. Here is where you specify the AWS WAF webACL that we want to use. So in our case, we are activating AWS WAF Security Automation 1. This is also a good time to double check if the access log is activated for this distribution. So you can see here that's not in this case, so let me activate it and point the access log to the bucket that we defined during the previous step. When I click yes edit, CloudFront will sync this information that we just added here, and when it's deployed, our solution is ready to run, and our application is using our protection rule set. Another thing that we can do now for customize this process is whenever a new request comes to this distribution, this request will be redirected to AWS WAF to be inspected, and AWS WAF say or returns that if this request should be blocked or not. If a request should be blocked, the CloudFront distribution will return at the full 403 error page. And here in this tab, we can customize this process to, instead of using the full error page, we can use a customized one. So I can create a new HTTP error code, HTTP sample page. In our case, let's reduce this to 1 minute, and I want to use a customized error page. In our case, in my case here, I have a custom error page located in this path here. But you can use whatever is available in your application. And here, let's keep the full value. When I do that, we're gonna have an architecture similar to this one. So we have a simple web application, our simple web application here, delivering content, static and dynamic content via CloudFront, and the CloudFormation template has provisioned these components for us. So that's it for the configured and using step. For those who want to dive deep and see how each component works, we can split those protection in scenarios like the first one, that if we want to use AWS WAF to inspect and block common or well-known signatures of exploit code. If we go back to our AWS WAF, we're gonna see that our protection set have a rule that will inspect SQL injection and cross-site script signatures, and whenever this kind of request comes into in our infrastructure, it will be blocked by AWS WAF. So the simplest way to demo this is going back to our sample page, this is our main page of our application. And if I get this application and post and send a signature of SQL injection, it will be inspected by AWS WAF and then will be blocked. The same things occurs when I try to send a cross-site script request, a request with cross-site scripting. Okay, if we go back to our architecture here, we're gonna see that AWS WAF contains some rules that will inspect this kind of request and then block for us. We also have space to final manual tuning about how this protection should work, and we can whitelist or blacklist some IP that we know that are bad origins. So if I go back to the AWS WAF and see the rules that we have here, we're gonna see that there is a whitelist for manual tuning and blacklist for manual tuning too. So if I go here, we can add it and add some IPs that we want to block or allow access. Another kind of protection that we want to block is requests that comes from suspicious origins. And the process is pretty simple. We have a event that trigger a Lambda function in every hour. This Lambda function goes toward the third-party list that we work for the solution, get those IPs that we should consider as suspicious, and then configure our AWS WAF protection to block the requests that come from those origins. If I go back to our AWS WAF page, we can see that there is two rules here with a set of IPs, and if I access this link, we're gonna see that there is a bunch of IP set that are currently being blocked by AWS WAF. Those IPs came from this kind of third-party list. The third example that this solution can help us to be protected is request. It's a protection based on inspecting logs to identify bad origins. So these two kinds of protection, like HTTP flood and scanning probes, will looking for information inside our access log files, and for every access log file that comes to our S3 bucket, we're gonna inspect it, and if some origins has made more requests than we specified as normal, in our case is 400 requests per minute, but you can edit it, it will be blocked for a period of time that you also can define. To simulate this process, I can go to S3 bucket where this Lambda function is configured to be triggered whenever a new file arrives here, and simulate a new access file being uploaded there. This sample file only contains a bunch of requests coming from my origin right now, my IP here, thousands of requests of my origin, and when I do that, the Lambda function will inspect this IP and block my access. So if I go back to my application and keep reloading it, we're gonna see that I was blocked. And why why my requests are being blocked right now is if I go back to AWS WAF console and go to the rules that we update those IPs that we identify as bad origin, like the outblock one, we're gonna see that my IP, let me find here, outblock. here. So auto block. My IP was blocked by this solution. So if we try to remove this IP from the IP set and keep reloading here, we're gonna see that I will get back access to my sample web page. So it's pretty simple. Whenever a new access log file comes to the S3 bucket, a Lambda function will inspect this log file, identify bad origin, and block them. The last sample that we have here is when we are trying to deal with bad bots and content scrapped, and we want to block them. This solution basically works by configuring a trap endpoint where you can add in your website a reference to it. So you just add a hidden link like this one that points to the trap endpoint that we have that we provision for you. And whenever a request comes to the CloudFront, access this trap endpoint, it will be handled by a Lambda function which will block this origin. And to avoid well-known bots or good bots to not access this link, we can configure robot.txt to say for good bots, don't access this trap endpoint. In the end of the day, bad bots won't respect what we define in robot.txt and will access the trap endpoint anyway. And when they do that, they will be blocked. The best way to see how this works is going back to our CloudFormation template. We go to the output tab and we can see that there is an output here that the endpoint. This endpoint is actually what we should point here in our hidden link. So simulating an access to this link, whenever I try to access this trap endpoint, it will be handled by a Lambda function which set AWS WAF to block our request, subsequent requests from our origin. So if I try to reload this page, we're gonna see that I was blocked. Now I will hand over to eVitamins so they can talk about how this solution helped them.
Hello, my name is David Ferrante. I'm the Senior Systems Engineer at eVitamins.com. Little background to our company: we were founded in 1999. We're an award-winning health and beauty e-tailer. We ship thousands of orders daily to over 85 different countries worldwide. We're localized in 15 different languages, and we're always adding more. And we're a trusted supplier for over 600 different manufacturers. Specific eVitamins challenges in the past have been to stop HTTP flood attacks, such as DDoS, prevent attacks and malicious activity in off hours, prevent known bad IP addresses from accessing our website, slap the wrist of anyone getting frisky, overwhelming our site with bad responses, make sure robots respect us. Many robots do not abide by standard practices. They like to flood websites with a lot of traffic all at once. And to stop SQL injections, cross-site scripting attacks from network layer in addition to the application layer of our website. Post AWS WAF security automations. After implementation, we're up to date on IP offenders from Spamhaus. IPs listed in Spamhaus are automatically blocked. Stop malicious activity around the clock. Automate temporary blacklisting. Force robots to follow and play by our rules. A lot of them do not. They flood websites with a lot of traffic all at once. And lastly, double up on SQL injects, cross-site scripting attacks, etc. to lessen the load on our website. And results and outcome after implementation. True ability to not miss anything. The script works around the clock, automatically blocking anything malicious. Mitigate damage in 90% time or less, from 3 hours to 20 minutes, in a lot of cases even less than 20 minutes. Reduce IT overhead. Less dedicated resources equals more time on other projects, and reduces our security overhead. Reduce tax on application layer by 90%. Increased sleep equals peace of mind for our IT team. No more 2 a.m. wake-up calls on the security side of things. Recommendation. This is a must-implement stack. It is without a doubt that anyone running any type of web application needs to implement the stack. We'd recommend giving AWS WAF a try, as the resources, insight, and control you have over the network layer for a web app is second to none. The ease of use and the resources needed to have such control over everything is highly appreciated. We definitely recommend implementing the stack as soon as possible. Thank you for your time today, and we appreciate the Amazon team taking the time to let us speak during this webinar. Thanks again.
Well, thank you very much, Dave, for that endorsement, and I'm really happy to hear that the AWS WAF product is helping you to sleep better at night. So the AWS WAF follows the pay-for-what-you-use model, which means you can get the protections you saw today starting at around $13 per month. AWS WAF's low-cost entry point means you can deploy protections to websites you couldn't afford to before. And what's even better, AWS WAF lets you reuse your web ACLs and your rules across many websites for no additional monthly fee. You just pay for the additional request volume. Go to the web address on your screen for step-by-step instructions and try out the protections you saw today. And once you've had a chance to get your hands on the protections and see how they work in the real world, come back and join us for a Q&A session to be scheduled in the December timeframe. Well, thank you very much for attending today. With that, I'll hand it back to Ryan.